In this question, different carbocations are given. We have to choose the most stable carbocations from the options given here. The stability of carbocations can be explained by using inductive effect and hyperconjugation. Inductive effect can be defined as it is an electronic effect transmitted through a chain of atoms in a molecule due to the electronegativity of the substituents, which can either withdraw or donate electron density through the sigma bonds. The next one is hyperconjugation. This is the interaction between the electrons in a sigma bond and an adjacent empty or partially filled p orbital or pi bond. This will stabilizes the molecule by delocalizing the electron density. Now let's come to the options given here. The first one is a primary carbocation. In this primary carbocation, combining these two effects we can see this will be less stable. And the second one containing positive charge on the carbon atom, which is a tertiary carbocation. This one contains 7 alpha hydrogen atoms. 3 hydrogen atoms are present in the CH3 group and 2 will be at the first position and second position. So due to the presence of these 7 alpha hydrogen atoms, hyperconjugation will be higher and they will be highly stable in their nature. And one more reason, due to the presence of this electron releasing group CH3, they can increases the electron density on the carbon atom containing positive charge, make the carbocation highly stable. As a result, option B is the correct answer. If you compare option C and D, we can see C is a secondary carbocation and D is another secondary carbocation. But here, hyperconjugation and inductive effects are there, but comparing to the compound B, the effects are less. Now the correct answer is option B.